All right, boys, welcome back. In the last video, we went through, this idea of correlation as a theory, and how two different sets of numbers can have a strong or weak or no positive, negative, linear, or even nonlinear correlation. So we're looking at how closely related two sets of usually numbers are. And here's an example of a trend that looks like it may be a linear, negative, strong correlation. So let's go ahead and see. So here's a world record for men for the mile run. And I was able just to grab this data set off the internet. I have no idea if it's valid or not. And for this intended purpose of this video, I quite frankly don't care, but it seems to make sense. So this, thanks to this data set and this website, I have a nice table of values that relate the year. So I'm kind of thinking about the year. That's my horizontal, my independent axis, and the time, the world record time. That's my y. My vertical axis for the world record. So in 1865, the world record for the mile for men was a little bit over 4.5 minutes. Okay. Scroll down to the last point on this data set, 1999. It was at 3 minutes and 43 seconds, and I'm sure it's less than that now. Okay, so regardless, we're going to use this data set. So what I did was I want to show you how to use the calculator to find a mathematical model for this particular correlation between the year and the world record for the mile time for men. So if we have a strong correlation, if we can find a mathematical function that models that, we call that function, by the way, a regression model or line of best fit if it is applying. And I'm going to show you how to do that now. So the first thing I did, in the interest of time, I just put some of these points in. It might be a waste of time to put all the points in, but I put some of these points in my calculator. And to do that, I have to go into the stat menu, and I'm going to edit. Okay, meaning I'm going to put in my first list, which is my quote unquote X, the year, but I decided to do year after 1865. So for me, I let 0, the year, correspond with 1865, right? And so in 1865, the world record was 4 minutes, 36 seconds, which when I convert to base 10, it's 4.6 minutes. Okay, so 1865, there's a world record. Okay, then if I toggle down, I get 10 years later, so that's 1875. So that's this data point right here. 1875, Walter Slade, pretty fast guy from England, 4 minutes and 24 seconds, right? So I went through the whole list and I did every 10 or so years, and I ended with the very last data point, which was in 1999, I believe, and the world record, whoops, here's 1999, 133 years after 1865. I'm off by a year. Okay, regardless, I put these values, years, world record for the mile time, in my calculator through the stat edit menu. Okay, in the interest of time, I already did that. Now, the next thing I want to do is I want to be able to see the data. So in order to see it, I'm going to make sure my plots are on. So I'm going to press second, y equals, see the stat plot, and I want to make sure my plots are on. So sure, the data's in there, but you have to tell the calculator to look at the data and then plot it. So you have to turn it on. So to do so, I press enter there. I make sure on is highlighted. And once on is highlighted, now the calculator can retrieve and display and can manipulate and crunch those numbers that are now in my statistical lists. Okay, once that's in, I'm going to press zoom stat. And what that does is it automatically makes my viewing window nice and clean for the data that I entered. And here it is, right? So that's 1865, 4.6 minutes, right? Okay, and it shows you each of the data points if you toggle through. Okay. Now, looking at this data now, my correlation appears to be positive or negative. That's right, negative. How do you know? That's right, it's trending downward. Okay. Would you say it's a strong negative linear correlation? Oh, I don't know. Oh, I think it's pretty strong. It looks pretty strong. So let's see if we can find that line of best fit and then the correlation coefficient R that tells us how strong of a negative correlation, in this case linear, the time and world record for the mile happened to be. Okay, so now to do so, to find that line of best fit, I'm going to go right into the stat menu again, and I'm done editing, putting my data in. I want to calculate, and I want to calculate what's called the linear regression model. Okay, this is called the line of best fit. But you know what? Before I do that, I forgot to turn my diagnostics on. So do this. I'm going to press second catalog. Okay. The reason I'm doing this is because I need to make sure that when I go through this process, it gives me R, the correlation. It will also give me the square of the correlation coefficient. But I'm going to go all the way down, again, second catalog. And that gives me a menu of all the options that are in this calculator. I don't know any easier way to do this. So I need to make sure my diagnostics, D, are on. So I'm almost there. Oh, there we go. Okay, you can see I have the diagnostics on. I'm going to press enter and enter again. Okay, that's important because without that, we're not going to get R, the correlation coefficient, which is very relevant. It tells us how good, how strong a correlation is, in this case linear. All right, so now I'm going to go back. I can quit that. I'm done with that. And now I go back into the stat menu. I already have it edited. I already have my lists in. I already have my plots on so I can see it. All right, now I want to find the function, the line that fits it. So I quit, home screen, and now I'm going to press stat, calc, and I'm going to go down back to the linear regression model. Okay, this is going to find me a line of best fit. There are lots of different types of mathematical functions that can fit data, two sets of numbers. In this case, L1 and L2, that's where I put my lists. L1, remember, is year. L2 is world record time for men. The rest of the stuff I can ignore, and I'm going to press calculate. Ooh. Okay, so what does that mean? Well, it means that the line y equals negative 0.0059998362. That's the slope, the a value, if you remember linear function, plus 4.4925. That's the y-intercept. That is the line that best fits the data. And, ooh, look at how close, how strong of a negative, in this case, correlation is. R, my correlation coefficient, is almost exactly negative 1, rather. Right? It's not far from negative 1. So this is a really, really, really strong linear negative correlation, the time related to the world record time in the mile for men. Okay, now I'm going to go ahead and I'm going to say, okay, I want to now see that line in my graph. So to do so, I have to remember the number 0.006 and 4.49. So I'm going to, in here, negative 0.0046, that's my slope x. Essentially, that's the per year decrease in the mile world record time, plus 4.46, which was the b value approximately that regression gave me. Now, when I graph that, ooh, there's my regression, and it's pretty darn close. Right? You can see how it hugs these points pretty tightly. Okay. Was I off a little bit in my calculations? Ooh, let's try it one more time. Stat, calc, linear regression. Here's a different way to show the linear function that best fits that negative correlated data. I can store that whole function in y1. So I press variables, y variables, function, y1. All right, so instead of having to remember it and probably make a boo-boo like I just did, because I had the wrong b term, now it has the exact line of best fit, also called the linear regression model. And again, it's the same thing I just did, but now it's going to plop it in y1 for me. Okay, rather than me goofing it up when I try to remember the numbers And because I'm getting old, I forget. Okay, now there's the correct line of best fit. And you can see how tight it is, how close the actual data points are to the line that best fits that data. Okay, so that's how I can get the line of best fit, the linear regression model for data. I put it in the calculator, stat edit. I can see it by turning the plots on, making sure they're on, and then hitting zoom stat, which is number 9. And then I can get the line of best fit in the stat calculate menu, linear regression, L1, L2, that's where my data is. I'm going to plop it in Y1. Again, I just did this, but I'm going to do it again. Right, so I don't have to goof it up when I remember and try to put it in. And there it is, right? Again, my R correlation coefficient is really, really close to -1. So it's almost perfect. It's a very strong negative linear correlation between the year time and the world record for the mile, right? And you can also see that, right? You can see that line of best fit really, all these data points, the actual data points are really tightly clustered about that line. Okay, so that said, it looks like every year, according to this line, the world record is going to drop a little bit, about 0.006 of a minute. There's your slope going down. Hope you enjoyed this video. We'll see you again soon. Bye-bye.